AI development programming frameworks, data cloud and domain knowledge. In summary, this course provides a comprehensive overview of the tools and techniques needed to build an AI. It covers programming languages, machine learning and deep learning frameworks, data manipulation and visualization tools, cloud computing platforms, and the importance of domain knowledge. Learners will gain practical experience in applying these concepts and tools to build and deploy AI models. This course is designed for individuals who are interested in learning about AI development and want to gain the skills necessary to build their own AI models. Building an AI can be a complex process, but with the right tools and knowledge, it can be done. Here's a simple step-by-step guide on how to build your own AI. Step 1. Define the problem. Before you begin building your AI, it's important to define the problem you're trying to solve. This will help you determine what type of AI to build and what data you'll need to train it. Step 2. Gather data. Once you've defined the problem, you'll need to gather the data that you'll use to train your AI. This data should be relevant to the problem you're trying to solve and should be in a format that can be easily used by the AI. Step 3. Choose a framework. There are many different AI frameworks available, such as TensorFlow, PyTorch, and Caffe. Each framework has its own strengths and weaknesses, so it's important to choose one that's appropriate for your project. Step 4. Build the model. Once you've chosen a framework, you can begin building your AI model. This involves designing the architecture of the model, selecting the appropriate algorithms and parameters, and training the model on your data. Step 5. Test and refine. After your AI is trained, you'll need to test it to see how well it performs. You may need to refine the model by adjusting the parameters or adding more data before it's ready for deployment. Step 6. Deploy. Once your AI is performing well, you can deploy it in a production environment. This could be a website, mobile app, or even a hardware device like a robot. Building an AI can be a complex process, but with the right tools and knowledge, it can be done. With this simple step-by-step guide, you'll be on your way to building your own AI in no time. To build an AI, you will need a combination of technical skills and domain knowledge. The specific tools and knowledge needed will depend on the type of AI you're building, but here are some common ones. 1. Programming language. Programming languages are a fundamental tool when it comes to building AI. They allow developers to write code that can be executed by computers, which is essential for training and running AI models. One of the most popular programming languages for building AI is Python. Python has a number of advantages that make it well suited for AI development. It is a high-level language, which means that it is easy to read and write, making it accessible to a wide range of developers. Additionally, Python has a large and active community, which has developed a wide range of powerful libraries for machine learning, deep learning, and data manipulation. Some of the most popular libraries include TensorFlow, PyTorch, and Scikit-learn. Another popular programming language for AI development is R is especially useful for data manipulation and visualization, and it has a number of libraries for machine learning and deep learning. To use a programming language for building AI, you would typically start by installing the necessary libraries and tools. For example, if you are using Python, you would install TensorFlow or PyTorch. Once the libraries are installed, you can import them into your code and start using their functions to build, train, and evaluate AI models. In addition to using libraries, you would also write your own code to define the problem you want to solve and to pre-process data. For example, you might use Python to extract data from a database, clean it, and format it in a way that can be used to train an AI model. In summary, programming languages are essential for building AI as they allow developers to write code that can be executed by computers, and Python is a popular programming language for building AI because of its ease of use, powerful libraries, and large community. 2. Machine learning and deep learning frameworks. Machine learning and deep learning frameworks are powerful tools that can be used to build AI. They provide pre-built models, libraries, and tools that can be used to train, test, and deploy AI models. One popular machine learning framework is Scikit-learn. It is built on top of Python and provides a wide range of algorithms for classification, regression, and clustering. It also includes tools for data preprocessing, model evaluation, and model selection. Another popular machine learning framework is TensorFlow. TensorFlow is a powerful open-source library developed by Google, which can be used to train, evaluate and deploy a wide range of machine learning models. TensorFlow is particularly useful for deep learning, which is a subfield of machine learning that involves training neural networks with multiple layers. TensorFlow provides a high-level API for building, training, and evaluating neural networks. Deep learning frameworks like PyTorch and Caffe are another popular choice for building AI. They provide pre-built models and tools for training, testing, and deploying deep learning models. PyTorch, for example, provides a dynamic computational graph, which allows for more flexibility when building models and is particularly suited for research and experimentation. Caffe, on the other hand, is focused on speed and efficiency and is often used in industry. To use these frameworks, you would typically start by installing the necessary libraries and tools. Once the libraries are installed, you can import them into your code and start using their functions to build, train, and evaluate AI models. For example, if you are using TensorFlow, you could import the library and use its pre-built models to train a neural network on a dataset. Once the neural network is trained, you could use TensorFlow to evaluate its performance and make adjustments as needed. In summary, machine learning and deep learning frameworks provide pre-built models, libraries, and tools that can be used to build AI models. Popular frameworks include scikit-learn, TensorFlow, PyTorch, and Caffe. To use these frameworks, you would typically start by installing the necessary libraries and tools, then import them into your code and use their functions to build, train, and evaluate AI models. 3. Data manipulation and visualization tools. Data manipulation and visualization tools are essential when it comes to building AI. They allow developers to prepare, clean, and explore data, which is a crucial step in the process of building an AI model. One popular data manipulation tool is Pandas. It is built on top of Python and provides a wide range of functions for working with data in a tabular format. It allows developers to easily load, manipulate, and clean data, as well as perform basic statistical analysis. Another popular data manipulation tool is SQL. SQL is a programming language that is used to manage data in relational databases. SQL allows developers to easily load, manipulate, and clean data, as well as perform basic statistical analysis. For data visualization, Python libraries such as Matplotlib and Seaborn are popular choices. Matplotlib is a plotting library for Python that provides an easy way to create static, animated, and interactive visualizations. Seaborn is a library built on top of Matplotlib that provides a high-level interface for creating visualizations. Another popular data visualization tool is Tableau. It is a data visualization software that allows users to connect to a wide range of data sources and create interactive visualizations. For example, if you are using Pandas, you could import the library and use its functions to load data from a CSV file, clean it, and perform basic statistical analysis. Once the data is cleaned, you could use Matplotlib or Seaborn to create visualizations that help you understand the data better. To use these tools, you would typically start by installing the necessary libraries and tools. Once the libraries are installed, you can import them into your code and start using their functions to manipulate and visualize data. In summary, data manipulation and visualization tools are essential when building AI. Popular tools include Pandas, SQL, Matplotlib, Seaborn, and Tableau. To use these tools, you would typically start by installing the necessary libraries and tools, then import them into your code and use their functions to manipulate and visualize data. 4. Cloud computing platforms. Cloud computing platforms can be used to build AI by providing the necessary infrastructure, resources, and tools to train, test, and deploy AI models. One popular cloud computing platform is AWS, Amazon Web Services. AWS provides a wide range of services for building, training, and deploying AI models, including Amazon SageMaker, a fully managed service for building, training, and deploying machine learning models, and Amazon Rekognition, a deep learning-based image and video analysis service. Another popular cloud computing platform is Microsoft Azure. Azure provides a wide range of services for building, training, and deploying AI models, including Azure Machine Learning, a fully managed cloud service for building, deploying, and managing machine learning models, and Azure Cognitive Services, a collection of pre-built APIs for natural language processing, speech recognition, computer vision, and other cognitive services. Google Cloud Platform, GCP, also provides a wide range of services for building, training, and deploying AI models, including Cloud ML Engine, a fully managed service for building, deploying, and scaling machine learning models, and Cloud Vision API, a pre-built API for image and video analysis. To use these cloud computing platforms, you would typically start by creating an account and signing in. Then, you can use the platform's web interface or command line tools to create and manage resources, such as virtual machines, storage, and databases. Once the resources are set up, you can use the platform's tools and services to train, test, and deploy your AI models. For example, if you are using AWS, you could use Amazon SageMaker to train and deploy a machine learning model, and use Amazon Rekognition to analyze images and videos. In summary, cloud computing platforms such as AWS, Azure, and GCP provide the necessary infrastructure, resources, and tools to train, test, and deploy AI models. Popular services include Amazon SageMaker, Azure Machine Learning, Cloud ML Engine, and Cloud Vision API. To use these platforms, you would typically start by creating an account and signing in, then use the platform's web interface or command line tools to create and manage resources and use the platform's tools and services to train, test, and deploy your AI models. 5. Domain knowledge. Domain knowledge is essential when building AI as it allows you to understand the problem you are trying to solve and design an appropriate solution. Domain knowledge can be used in various stages of the AI building process, including data collection, feature engineering, model selection, and evaluation. 1. Data collection. Domain knowledge is crucial in identifying and collecting the appropriate data for the problem. 1. It allows you to understand the types of data that are relevant to the problem, as well as the sources of data that are available. 2. Feature engineering. Domain knowledge is also important in feature engineering, which is the process of creating new features from the raw data that can improve the performance of the AI model. 2. Domain knowledge allows you to identify the important factors that affect the problem and use them to create new features. 3. Model selection. Domain knowledge can also help in the selection of the appropriate AI model. 3. It allows you to understand the characteristics of the problem and choose a model that is best suited to solve it. 4. Evaluation. Domain knowledge is important in evaluating the performance of the AI model. 4. It allows you to understand the problem and set appropriate performance metrics, as well as interpret the results of the model. For example, if you are building an AI model for diagnosing diseases, your domain knowledge would include an understanding of the symptoms and causes of different diseases, as well as the types of data that are relevant to the problem, e.g., medical images, patient history, lab results. This knowledge would be used to collect and select the appropriate data, engineer relevant features, select an appropriate model, and evaluate the model's performance. In summary, domain knowledge is essential when building AI. It allows you to understand the problem you are trying to solve and design an appropriate solution. Domain knowledge can be used in various stages of the AI building process, including data collection, feature engineering, model selection, and evaluation. It allows you to identify the important factors that affect the problem, select the appropriate data and AI model, and evaluate the performance of the AI model accordingly. 6. Familiarity with neural network architectures. Familiarity with neural network architectures is important when building AI because it allows you to design and implement appropriate models for the problem at hand. Neural network architectures are the underlying structure of an AI model that determines how it processes data and makes predictions. 1. Model selection. Familiarity with neural network architectures allows you to choose the appropriate architecture for the problem. 1. For example, if you are building an AI model for image classification, a convolutional neural network, CNN, would be a suitable architecture, whereas for natural language processing, a recurrent neural network, RNN, or a transformer-based architecture would be a better fit. 2. Hyperparameter tuning. Familiarity with neural network architectures also allows you to fine-tune the hyperparameters of the model to optimize its performance. 2. Hyperparameters are the parameters that are not learned from the data, but are set before training the model. 2. Familiarity with neural network architectures allows you to understand how different hyperparameter settings affect the model's performance. 3. Model interpretability. Familiarity with neural network architectures can also help you understand how the model is making predictions and identify any potential issues. 3. For example, if you are using a deep neural network, it can be challenging to understand how the model is processing the data and making predictions. 3. Familiarity with neural network architectures allows you to interpret the model's behavior and identify any issues that may be affecting its performance. 4. Model optimization. Familiarity with neural network architectures also allows you to optimize the model for performance and computational efficiency. 4. For example, you can use techniques such as pruning, quantization, and distillation to reduce the number of parameters in the model and improve its performance. For example, if you are building an AI model for image classification, a convolutional neural network would be a suitable architecture. Familiarity with CNNs would allow you to understand how the different layers of the network process the data and make predictions, and to fine-tune the hyperparameters of the model to optimize its performance. In summary, familiarity with neural network architectures is important when building AI because it allows you to design and implement appropriate models for the problem at hand. Familiarity with neural network architectures allows you to choose the appropriate architecture for the problem, fine-tune the hyperparameters of the model, understand how the model is making predictions and identify any potential issues and optimize the model for performance and computational efficiency. As you complete this course, you should now have a solid understanding of the various tools and techniques needed to build an AI. You should have a good grasp of programming languages and their libraries and frameworks, be familiar with machine learning and deep learning frameworks, know how to manipulate and visualize data, understand the basics of cloud computing platforms, and have an appreciation for the importance of domain knowledge in building AI. With this knowledge, you should be well equipped to start building your own AI models. We hope this course has been valuable to you, and we wish you all the best as you continue your journey in the field of AI. Thanks for watching. We hope you found this video informative and helpful. Remember, at Skills Vantage we're here to help you stay updated on the latest skills and technologies in the industry. If you liked this video, be sure to give it a like and leave a comment. Also, don't forget to subscribe to our channel for more videos like this. Your support will help us to continue creating valuable content for you. Thank you for watching, and we'll see you in the next video.